Yes, hi. That's the quote, right? So I'm here today to tell you a little story in 4 parts. But anyway, I'm Daniel. I'm the president of the European Open Source Academy. I work for foss-north. That's my site. I work, as some of you might know, on curl every day, all day, as much as possible. In curl, we ship a product or products that runs in a lot of places. And whatever you do is shipped and deployed and used in many places. You get to, security and making sure things are done right becomes more important. At least it does for us. And as every good story, I'm going to start with a little prologue. Back in the day, you might not remember that, all of you, but we actually had this artisanal era where we actually, we wrote code manually. People were still doing that, And it's a pretty time and energy intensive thing. And to verify code, we used to read code, find the problems. We would enable all the compiler options, run code analyzers. We would do fuzzing and do whatever we needed to do. And in order to when we use all the tools, how would we find the security problem in all of that code? We would use human eyes. We would read the code, grep for patterns that we know are bad or usually involved in bad code, or people would write their own custom tools. It would actually take a while to do this. And sure, people have been doing security research for a long time, and people have been really good at it. Over time, in the current project, we've certainly seen that certain specific individuals have come back over and over because they've been really good at this, and they have then used their own tools and approaches to find problems. So this is how we used to do. It's finding security problems have been very time and energy intensive, and it took time and it was hard back in this artisanal era. And then, because it took time and it was hard, we could offer people money when they actually found a security problem, because that would then give them incentives to actually spend that time and energy to find problems in my crappy code. It worked really good back in that day. And bug bounty is then only one particular thing you could do to do something securely, right? There are a lot of components and pieces that combined possibly could make your software secure. And of course, bug bounty was one little piece in this puzzle. And yeah, AI existed, but it really didn't bother us. This is back in the 2024 days, the good old days. That's the prologue, right? That's how we started back in the day. And then we started episode 1. The slop era started like this, or with a sort of subtitle, The Awakening. Suddenly, someone out there, the tech giants suddenly imposed AIs to the world, generative AI, chat things all over, and we started to realize that, hey, we can ask an AI and it'll answer and it'll give us something that it thinks is right, and we think it's right, and we will report that to whoever we think should get that. So this really opened the floodgates, right? Ask the AI, find a security problem in this product, and it would give you a security problem, maybe. So this really opened the floodgates for a lot of AI slop, right? Crap. And it could look a little bit like this. This is one of my favorite. I've shown this before, so maybe, sorry, wrong order. But so it started like all the regular AI characteristics. Very confident tone, overly polite, nothing really of substance in there. Hallucination, APIs that they don't exist, or maybe just made up buffer overflows that actually didn't exist in the product. Technical nonsense, lots of air, and work for those who receive this. And like in this example. So this is from 2025. Yeah, May 2025. An HTTP3 stream dependency cycle exploit. Lots of details, patch the test server, explain how it runs, and here's a crash, and really bad, show GDB, register dumps, this is really bad, and then risk summary bullet points, but they're all lies, right? The function that had the crash, it doesn't exist, all made up. The GDB session is fake too, because it showed things that the GDB can't really show. The registers are wrong. The crash doesn't happen. It was all just, movie style, made up. Nothing is real in this. And this is what we have in this era. So, slop, annoying, and super toiling on your mental capacity, just getting all of that over and over, stupidity. So a really signal to noise bankruptcy, right? Volume up a lot, because now you don't have to spend time and energy on finding these security problems. You just ask the AI and it'll tell you. I mean, what took hours before took seconds now. And you didn't have to know anything, you didn't have to spend anything, because they were also very cheap, right? So quality really fell through the floor. Lots of volume, really crappy. Yeah, so there's triaging this gets really annoying and just exhausting. This isn't real so many times to the extent that whenever a new security report ended up in my inbox, it was like, what kind of fantasy have they come up with now? To really switch around from, oh no, something bad has happened, to, oh no, something new has been invented that just is crazy. So we decided that there was too much craziness. We stopped the bug bounty because we don't want to have that as an incentive. You won't get any money when you just ask an AI, and the AI will make something up for you. So we stopped that. And I talked about that. And this is not long ago, right? February. It's just a few months ago. We stopped it. No more money. And at the same time, we also said we would abandon HackerOne, because why use HackerOne when we don't have any bounty anymore? We would go over to do everything on GitHub, like so many others seem to do. And initially, this was good. And we also then started using a little bit of AI code analysis ourselves, to scan through the code, find problems, and address them over time. And I talked about all this already in my talk on February 1st. And this was the state then. The slop era, I would say it possibly peaked a little bit before that. And so we switched off the bug bounty, we moved away from HackerOne, and that takes me to part 2, right? Part 2 of this is really, it's switched around. The reality is no longer like that. It's now completely different, because something happened in those few months since February 1. Maybe it started before that. But we started out, okay, we shut down the bug bounty, we moved over to GitHub, and we realized that nothing. Well, that was it, right? No more crappy things, because now they wouldn't get money. Now they had no reason to ask the AIs and just submit slop, because we wouldn't pay them anymore. Was that the solution? I think we actually believed that maybe for a few weeks. Was that going to be the future now? Great. We started adding some even more AI tools, so we scan curl with different tools, basically code analyzers that are spiced up with AI, and we do code reviews with some of those AI things as well. They're pretty good, and they help. We realized also that switching to GitHub was not at all a good idea. It's just not good enough, I think. Primarily because transparency, I think, for this open source project is really mandatory and a top priority. So I think for a project like her, I think it's really valuable that we can publish all the reports that we ever got, all the crap ones as well. If someone has reported a problem to us, we can publish it once we've dealt with it. And that's not possible on GitHub. So we ditched that. And we went back to HackerOne, but still no bug bounty. Okay, maybe all of that doesn't really matter, but we did that then, beginning of March. Still not long ago. And the reports are back. Bam. They weren't gone. Maybe they were gone because people didn't want to submit them on GitHub. But I don't think that's really the truth either. So the rate of reports have not slowed down. They come back. And they come back at a higher rate than ever before. And the slop is gone too. So suddenly, all of those crap reports we were used to, they don't happen anymore. Now people are submitting really good reports, and we can still tell that they're made with AI because of the formatting, right? It's overly polite, it's very long, very detailed in ways, and phrased in ways that you don't actually normally speak as a human. But good. So, high quality in large volumes. That's the sort of the summary of my whole talk here today and of this era. So now suddenly, previously it was really annoying to get all of that slop and crap in large volumes, and it was sort of exhausting to say, no, not real, no, go away, you're being rude to do this. And now suddenly it's a completely different thing, because now when you get a lot of reports and they're mostly accurate, that's completely different kind of overload, because now I can't just dismiss them and say, go away, you're annoying, because yes, it's annoying, but it's true. And of course, all of these, almost all of them are made with AI-powered tools. I say, the reporters rarely actually say that, because I think reporters tend to still believe that they did a good part of this. It wasn't the AI, it was the security person who prompted it or did whatever, but you can often tell by the report that there's certainly AI involved here. And AI is really good at finding bugs. It's really good at finding, pattern-breaking behaviors or things that you do that once but no other time, so it'll find that for you. But all those times when you get a report from someone that found the problem with these AIs, and this goes to all of these AI-powered tools, they're really good at finding problems. But is the problem a security problem, or is it just a bug? I mean, that's really hard for anyone to say, right? What's the difference between a bug and a vulnerability? In most cases, it's a very gray area. Who's to say that? It needs someone to actually analyze, understand the concept, the threat model, blah, 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 what's involved. And the AIs tend to then be exaggerated a little bit. So people tend to report more problems, of course, than they actually are vulnerabilities. But a lot of them are bugs. And getting bugs reported is good too. And of course, when people do reporting like this, using tools, they tend to end up with duplicates much more often than otherwise. Because when humans did this, they spent hours on finding a problem. It's really rare that two separate individuals would independently find the same problem in the same period of time, because it was like, who's going to find two needles in a haystack, right? But now when the tools do this, two people run the same tool, they might, or even likely, to find the same things. So now we're in a situation where people keep reporting the same problems in a very detailed, specific ways, right? Because they're generated with AI, but they report the same problems multiple times. I mean, and that's not really a huge problem, more of a description of the reality. And they tend to be, something happened over this period, right? Because now they're technically correct, almost always. So they're well formatted, and they're explaining the problem usually pretty succinct, even though they tend to be very long. Also because nowadays they also generate a lot of proof of concepts code, proof of concept servers, proof of concept blah, blah, blah. So every report is now huge, which could be good when they're correct. So yeah, they're often polished and professional, often wrong about the security context. Often they're just, they identify a problem. Is this problem a security problem or not? In many cases, they're not. But I would say they're shockingly often accurate. And to give you an idea of how the nature have changed, I went on and talked about AI slop so often, so I'm now I feel it's my responsibility to tell everyone that the AI slop days, they're really gone. We don't see AI slop anymore, to the extent that it's basically back to the level we were back in 2024 or something when it comes to slop. The volume. So back in 2020 to 2024, in the curl security team, basically we had an average of 100-something hours between each report. That's like one and a half report per week. And you can see that was for 5 years. That was sort of the standard rate. In 2025, something happened, right? Then sort of the frequency more than doubled. And so much AI slop at a very high speed. And in 2026, again, we doubled the rate. So as you can see, now we get more than one a day on average, compared to, so that's like 20 hours per report from the 110 or whatever it was before that. So a lot more. And how big share of all those reports are actually, in the end, confirmed vulnerabilities? No, sorry, this is how many of them are bugs, not vulnerabilities, but they still report a bug, right? And a reported bug is still a bug, right? And we want to fix that, so that's still a kind of a good report. It's not a security report, or it's not a security problem, but it's a bug and we want to fix bugs. So suddenly that quality sort of, almost a third of them identify a bug, not a vulnerability. But it used to be more of every 1 in 5. And then how many of them identify a confirmed vulnerability? Back last year, the AI slop year, basically 2025, it was not very good in 2025. But the confirmed vulnerability rate is now better than it was even in 2024. Basically, the pre-AI days, we're now beyond that. We're even better than. So basically, we went from this no AI, slop AI, good AI. And nowadays, no one is using sort of just pure human security research. They're all involving AIs in a certain extent. And yet, it gives us high volume, high quality, lots of vulnerabilities and lots of bugs. So yeah, but just to emphasize, so what is an AI slop here? That's just me reading a report and saying, is this slop or not? So it's very error prone, it's very subjective what I decide is an AI slop or not. But even take that into account, just shows that we had a problem in 2025 with this. It was huge for us. It's gone now. So we're back to, somewhere 1 in, I don't know why, 1 in 10, 12, 14 is a slop. And then I mean, by slop I mean more people have used AI in a bad, sloppy way without checking the details, maybe claiming completely inaccurate facts or whatever. And for this then, all of those reports that now are high volume, high quality, very accurate, they're still easy for those people to generate, in many cases at least, because now the tools are so good doing this. And they're still, actually, they're probably even harder to process now because they're more accurate, they're very detailed and very long. It takes a long time. I would say it takes on average of a few hours per report. And they rarely contain fixes. And there are many explanations why they don't fix things, because fixing things is certainly the hardest part of all this. Identifying a potential problem is much easier. And the tools are very good at identifying a potential problem, but they're less good at actually fixing the problem. because that's the hard part. So even though there are really capable AI tooling to do this, the AI tooling can also often suggest a fix, but in more cases than not, they actually suggest a fix that's incomplete or wrong, or, well, at least not the fix you want. So, yes, we need to receive every report that says, is this real? Is it a vulnerability? Is it just a bug? It takes hours, and the higher quality reporting, the more time I would say it takes. And sometimes it also takes just because now they can explain the entire sequence in a lot of words, and that sometimes takes a long time. But it takes a long time, and it's hard to actually just follow, understand what do you mean? What kind of an attack is this? What's this vulnerability? So yeah, and once confirmed, I would say it's usually fairly easy and quick to actually fix the particular problem, because usually once you realize, oh, right, stupidity, it's almost, for some reason it's almost my commits that I introduce the problem. So, once I realize what the problem is, then it's usually also decently easy to fix them. So we only see this really in security reports and not in any other areas in our project really. And I don't know exactly why it's like that. So people actually don't use this very much for normal issues, and we don't see it much for pull requests either. So we don't see a lot of AI infested or increase in these areas yet, at least. As I said, I don't know exactly why, but we certainly see it in security reports. And right. So, and you may then sort of ask, so what's the difference? What changed from before to now? What do these two do that they didn't do in the past, right? So if you haven't used these tools, if you haven't seen them, so say curl is a traditional old-style C project, right? How do you find problems in C code? Typically, in the old day, as I mentioned previously, you use picky compiler options, you use code analyzers, you do fuzzing, manual reviews, and all of those things. And one of those limitations when you do a code analyzer or you use picky compiler options is that you actually have to compile the code, right? It will only check the code that you compiled. And to compile the code, it has to build, or your code analyzer has to be able to build that particular build to analyze it. Which, like in Curl's case, we have 40, 50 different build options. We can build on 100 different operating systems. It's really hard to build and run the code analyzers on all the code. Basically, it is impossible. That means that we have a lot of code that no code analyzer ever could actually analyze because they could never build it. The AI tooling is not limited to that. It's just it reads text. It doesn't really care where it runs or not. It can read anything, which is a really big improvement, because now it just reads the code and analyzes it. Suddenly you can find problems in code that was never analyzed before. Or, features that is disabled almost always, now we can analyze them. So it's not restricted to platforms either, right? So now we can analyze that code that we have. We have a particular set of source codes that only runs on what used to be the OS 400. It's an IBM operating system called IBM I these days. We have like one contributor who ever uses that, so that's really rarely built, rarely used, and certainly never analyzed by a code analyzer, because I don't know anyone with a code analyzer for OS 400. But suddenly, the AI tooling can, because it just reads the code, points out potential problems. And these new toolings, they also cross boundaries like no tool ever did before. If you're using a library you write code, you use a library in your code, right? Previous analyzers, they analyze your code. They don't know about the outside world. They analyze your code. But the outside world and you interact, right? You get data back from an API, or you use something and you get data back, or interchange. These new tools, they can certainly know about the other reality as well, and they can point out, hey, you're using this external library wrong because you assume that the data is blah, 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 but the documentation for the function actually says this in ways tools never did before. And at the same time, in a similar spirit, they actually know some of the spoken protocols. Carl, back to Carl, it speaks a lot of network protocols, right? So it speaks as Telnet, IMAP, POP3, HTTP, or whatever. And the tooling here, it actually knows about those protocols. So it can actually say, hey, in your code here, when you send these byte sequence over Telnet, you're actually not sending it in the right order because of this paragraph in the specification that actually says something else. In ways, again, wasn't done before. So all of this taken together makes, of course, that this finds things that only humans found before. And only very skilled and dedicated and patient humans, typically no human, because it's so boring and it takes so much time. Yeah. So, yeah. Oh, one of my favorite things is when it actually remarks on the comments being wrong, right? The comment above the function says that the function does this, but the function doesn't actually do that, right? It's a discrepancy. And why is that good? I think it's excellent, right? Because if the comment is wrong, I mean, all the users of my function will read the comment and think that's how the function works. But if it works differently, that's certainly a bug waiting to happen. So it's an excellent way to get that fixed as well. And some of these tools are also very good at generating patches and even test cases. So I have some of those that say, hey, I found this problem, here's the fix. And here's also an addition to the test suite verifying my fix, which is cool when it works. It tends to not be complete and fully functional, but it still is going in that direction. And it's pretty cool. And of course, some of them also build reproducers. And I use one of these tools that actually build reproducers. It finds a problem, it builds a reproducer to verify the problem, and then it builds a reproducer to verify its own fix, so that it has some kind of confidence that whatever it suggests as a fix, it actually verified that it's fixed that particular problem. It's a fascinating development. And we're only scratching the surface. It's going to get better. Which takes me to my third episode here. We're coming into the drowning. Because now, these tools find a lot of problems. I mean, the problems are not really new. They're there, right? We planted those problems potentially a long time ago, and we've been living with them for a long time. But now suddenly, all these tools are going to get them up to the surface. We're going to see them now. And I asked around on Mastodon, actually, for other projects that see the same pattern, that is high volume, high quality security reports. And these were some of the projects that says, yes, we see this as well. So it's not a curl thing. It's not a uniquely my problem here. This is widespread. It's everywhere. Everyone is seeing this. High volume, high quality security reports. And the sort of following on challenge, what do we do with this? How do we handle it? Because, of course, it's not like all of those reports came with more maintainers or more volunteers or anything. It's just same amount of people at most, and now just a busload of more reports and problems that have sort of everyone is shoving down to us. So, and we haven't got more money, and people are still overworked. So I would say this is certainly a time where we're putting even more load and even more anticipation that all those maintainers out there are going to sort of now fix all those problems that we so eagerly can find and report to them, or to us. So I think this is going to be even more emphasized in this era. And when I explain to people that this happens right now, then everyone comes back and tells me, well, you stopped the bug bounty. So, that's why the slop went away. But that's also my message here. That's not at all the reason. First, we can say that it doesn't matter if HackerOne or anyone else did anything different on their platforms. That's not an explanation for this, because we're using all platforms, right? All of those projects I mentioned, we're on everything, right? Or nothing. It doesn't matter on which platform, because this trend is seen everywhere. It doesn't matter if I shamed people who submitted slop in the past, because most people did not, and they still see the same trend. And it doesn't matter that we dropped the bug boundary, because most of those projects that I mentioned before, they never had any bug boundary, or bug boundary doesn't matter anymore. Anyway, we all see this trend. It doesn't matter what we do. And so the only reasonable explanation I can find for this is simply that the tooling has changed. It's simply better now. And the internet bug boundary, which Curl was a part of when we said no more bug boundary, they also then eventually decided that they have stopped the bug boundaries for all of their projects completely because of this same trend. So easy to generate, you get so much quality, so there's no point in paying the money like that anymore. And the AI tooling is going to keep improving. Some is going to say that it's going to be dangerous to the world when we introduce new models. And maybe it is dangerous, and it's not going to stop with a specific certain model. And it started way before this particularly dangerous model. So it's a trend that is already started and it's going on. And how much is it going to improve? Someone told me actually just yesterday when I talked about this that imagine that the tooling got so much better, and now we get this influx of a lot of problems, and we fix them now, right? If we're able to, we can fix the problems quickly, and if we manage to do that, that's good. But is that the end of this? How much more are there going to be, right? If the tooling enhances by 10%, is that going to give us 10% more reports? I mean, but where does it end, right? How much better can it be? How many more problems are there? And we're going to continue changing things, right? All of us run and participate in projects that we haven't really came to the end, right? Not yet. We haven't added the final feature, we haven't fixed the final bug just yet, so we're going to keep on changing, people are going to keep on finding problems, and the tooling is going to get better. And I find it also very interesting that several times during the last half year or so, I've added a new one of these tools and asked it to scan through code. And basically every time I do that, the new tool finds a lot of new things that the other tools didn't find. So I also imagine that it's not only about adding or improving the existing tools, it's also about coming up with new tools and new players on the market that are going to find new things in your projects, and you're going to get them reported. So the report load, I think, is going to increase further for a good while forward. And so what's the end result of that? I think, going back to the project I'm closest to, I just count. So I actually, in about 22.5 hours, I'm going to do a new curl release. In that curl release, I'm going to publish, I think, at least 8 new CDs, which takes us to 18 CDs for 2026 so far. 18 CDs in the first third of the year, right? So if we then extrapolate for the rest of the year, it's going to make a fun year. And I don't think curl is unique or special in this case either. So I think, sure, the numbers are going to vary between project to project, and people are reporting problems differently, and the numbers are going to vary, but the trend is clear. It's going to be like this on many more projects. So it's going to be many more security vulnerabilities published in this year than ever before, even if some of them won't be CDs, of course. So yeah, and again, these bugs already existed, right? It's not like anyone actually introduced them now. Out of those 8 CDs we publish for curl tomorrow, I think the oldest one is over 21 years old, and I think the average age of them is like 14 or 10 or something, so they tend to be really, really old anyway. So these tools just helps us, they help us just surface the bugs that's already in there. And fixing bugs is good, right? So overall, if we just manage the load and the incoming feed of all those issues, this makes our products so much better. The challenge is just to handle the load. And I have no expectation that we're going to get more maintainers or more help in general. We're just going to get more work. And people, companies, they still like free, as in free beer. They're not going to pay for this in any particular higher degree than they did in the past, because that's how market economy works. So yeah, I think the backlogs will grow, basically because we will now get much more to do without so many more hands to do the fixes or handle the reports. So there's going to be more vulnerabilities published, and there's going to be more vulnerabilities out there that we haven't published because we haven't managed to get to them yet. So it's going to open up an opportunity for whoever is looking for that opportunity when there's a lot of potential vulnerabilities that aren't fixed yet, or anyone can now find vulnerabilities much easier in pretty much any product that are not fixed yet. So whatever you want to do with that, it's of course up to all those that run these tools. So the question is, of course, if this is the new normal, are we going to see this influx going on for a long time, forever? Are we just going to have to get used to this? And what do we do with this? I know lots of people then suggested that we should just ditch the concept of handling vulnerabilities the way we have done in the past, because it's going to be really hard to manage all this. And because of all the duplicates we get now, because all those tools find the same thing. So the longer time we now do between releases, the more duplicates we're going to get reported. And getting duplicates reported is also adding to the workload. But we still have to have some time between releases, or do we? Yeah, maybe we should do faster release cycles. And I would say that in many cases, as some people have suggested, well, it's going to be the end of open source. But there's no, I cannot understand how anyone can imagine that going non-open source is going to be better. It's not going to help you to just hide your code from the world. It's not going to fix your problems. The problems are there anyway. So I think, in general, this is much better for open source, because the open source is here in the open. We can help out and fix them, and anyone can check your code and fix your code, and it's going to make better code. I think the situation is much more grim for the world that is not open, because non-open code tend to be much worse in general, so they have an even bigger problem. When they run these tools on their proprietary things, they're going to get an even more sort of load and challenge to handle all this. So yeah, the question is then, higher frequency of vulnerability reports, more releases. It's going to be a question of how fast can everyone then patch their stuff, because we're going to have to release updates more, faster, and with more published vulnerabilities. So everyone who uses all of these open source products in general, are going to have to, as usual, I mean, this is not new either, right? We've been publishing vulnerabilities for a long time, so it's just going to emphasize it even more, that it's going to be important for everyone to just keep up with all of those dependencies, that you really should upgrade to the latest secure version, because we're going to have even more vulnerabilities published for everything that we depend on in this era. So, that's the reality. Thank you.
Thank you, Daniel. Questions?
Hey, thanks for a good talk. What's your take on, if you had time to do an analysis about the impact of the Cyber Resilience Act in the context of, increasing speed of security reports?
I think the CRA is it goes hand in hand with this, because the CRA is going to make everyone have to keep up with all the security reporting and make sure that they update. So I think the CRA is a legislation that mandates everyone to do what I say here. But I'm also saying that it may be the trend with all this, with this higher pace in vulnerabilities and more vulnerabilities, is going to make it harder for those who needs to comply with CRA. I'd just say that, so it's just going to be more work for them. But I'm a fan of CRA. I think CRA is a good direction. So, yeah.
At some point in the talk, you mentioned that you run again the tool and it finds new issues. And you're saying it's going to keep finding issues. But somehow, nothing is infinite. So there's not necessarily an infinite number of vulnerabilities. So won't the AI at some point go to the end of it? And when you mention that they find new things, are they not finding new things because you already found the prior ones? And doesn't AI have a tendency, didn't you see the AI having a tendency just to find the most easy bugs and never going further? So couldn't there be also an interesting solution to the risks around AI finding issues, to leave issues that are not issues, and that the AI thinks it's going to be bugs?
But if they're not issues, they're not issues. Then they're not even counted in my numbers, right? If you report something and it's not even a bug, then it's just rubbish. Then I don't count that. That's sort of, it doesn't matter. But, okay, so the question is, really, of course there's going to be a plateau at some point. You can't just keep finding things forever if you don't change the code at least. You have to, at some point, run out of findings, right? At some point, you actually can fix the final bug. At least, I get that's a theory, at least, yeah, right? So, of course, there's going to be an end at some point. The question, to me, I think that's a little bit of a, it doesn't really matter, but because the question is, if it takes 5 years to reach that point, maybe that's forever in my mind, anyway, because then it's going to be an intense load for the foreseeable future, and that's what I'm talking about. It's, of course, the tools will also stop developing and developing at some point, and yes, it's going to settle somewhere, but until then, we have so much code, so few maintainers, so that it'll sort of keep us occupied for a very long time. So it's actually enough if the tools keep improving for just another year or two. It's going to keep us occupied for another 5 or 12 years. And who knows what's going to change as well in this time, right? This isn't the only thing that happens in the world, I think.
I assume you have access to Mythos. Is it all hype? Or what do you think?
I don't have access yet, actually. I'm a little bit disappointed because I was supposed to have it before today. So I wanted to have that and have that mentioned here today. But unfortunately, that has been delayed for some unknown reason. So I don't have access. I can't talk about it. I can't really comment on how good it is. But I also want to then maybe emphasize that all I've said here, the current trends, all this tooling, has happened long before someone ever mentioned Mythos in public. So that this happens sort of independently of Mythos or not. Then maybe Mythos is much better than all the other tools and everything else before. To me, it's not that important because we're already seeing this. This is already happening in Mythos or not, right? So everyone can already find a lot of problems and we already have this reality now. So sure, it can maybe, as I said, it can get even worse if the tools get even better and we get even more reports. And probably it will. And maybe Mythos will contribute to that, or maybe not. I guess we'll just have to find out soon.
Hi, Eric. I first want to commend you because you're one of the guys where the buck stops here at big projects or well-known projects. So you have been not taking sides of AI is good or bad. You have been able to have more than one thought in your head. That has been very much appreciated. When it comes to the problem of filtering out duplicates, of course you can't publish what you haven't really processed. But what if, and with all these well-funded AI posing universities, you might get help from researchers, or we might demand researchers to work on some way to compress with high entropy encoding of what the AI is actually reporting, so that you could filter out duplicates. That would be either some clever OSS developers, or is something that we could require from all these people that get money for research with AI and security.
Yeah. And I know there is more work going on in more places to manage. Basically, what I've talked about today is more of a description of how things are. Then there are actually several different players that are trying and thinking about different ways to help balance this out. So I know, for example, that the internet bug bounty, that stopped the bounding part, they're also thinking about how they can do basically that, help out with detecting duplicates and early triaging of these incoming reports. It's really hard work to actually determine whether a report is a kernel security problem or not. I get so many suggestions. I could spend days just replying to all of those silly suggestions I get from people. Whenever I talk about this, I get an inflood of emails from people saying that they have solutions for this. Either they all do it with AI, or they're going to sort of just magically help me sort out my security reports. But, I mean, we have this problem because someone thinks there's a security problem in curl, which is network C-oriented stuff, right? And how do you determine if that is a security problem or not? You actually have to be really well versed in the protocols, the language, the APIs, the documentation, the surroundings in order to assess that. And that's why I'm always sort of skeptical to just handing that out to someone else, because those someone else already did the bad job when they submitted to us. And I don't think any random engineer is going to help us here. It's going to be someone who really needs to know the area and needs to be ambitious enough to really be there. That's why I think I would much more prefer to just people to join the curl security team and get them into the team, and we will work with that in the team rather than thinking that the outside world is going to help us much. But that's just me being stupid.
Hi. So you say you suspect that the volume of work for open source maintainers will grow with these tools, whereas the resources at the community's disposal will perhaps not grow, at least in the same
Absolutely.
at the same rate. So I guess this is an age-old question, but do you think there is a way we can get these big companies that reap the benefit of the labor of the open source community to actually fund the projects?
I would really love to say, yeah, we should do that. Or rather, I could say that, yes, we should get them to pay more and help out more. But that's a mantra we've been saying for ever since we coined it, or even before we coined the term open source. Because it's a market economy. If they can get away without paying, they often will get away without paying. So yes, but we really should continue to make sure that those who reap the benefits are sort of help out. And back to the CRA discussion, they are in some ways obliged to help out at least soon. So maybe there is a light in the tunnel.
Because you've been in this game for quite a while. Do you have a gut feeling what the most effective tools at our disposal are? Whether that's like lobbying the companies, or is it something from the community itself?
I'm actually a pretty bad person to ask that, because I'm really bad at getting funding myself, I think. So that's actually one of these things that I struggle with pretty much still today, to get people to actually pay for things so that I can actually keep doing what I do. So I don't have there are no easy answers to this. And looking around at what open source projects and companies do, there are a lot of different ways, and they seem to work differently to different companies in different times and areas. So there are no easy solutions there. But I think we're just going to have to continue to try different venues and different ways to get funding, get more maintainers, because it's going to be a lot to do.
Thank you, and thank you so much for your work.
I'm curious to know a little bit more about the characteristics of the vulnerability that these tools finds, and how it is perhaps different since you started doing the bug bounty. Because I assume that the people who want to get money from the bug bounty, like the old school humans, that they perhaps find a certain type of vulnerabilities that have attack patterns that require more context to understand, or like has the average severity increased or decreased? So if you could talk a bit more about the vulnerabilities that actually pop out, and if you lost something by stopping bug bounty.
Well, it's really hard to know if we lose something that we don't get, right? And because all vulnerabilities are in some ways unique, so, and when we don't get them, do we know if we don't get it, or do we get them? I don't know. I would say that in general, the severity of our vulnerabilities have decreased over time, but I think that might just be a question of maturity of the project, so maybe that's just natural that it should be like that. And I would say that when I look at, for example, I think tomorrow I'm going to publish 8 new CVs, and I think all of them probably were found to some extent with AI. And looking at these 8, I can certainly see a pattern, what the AIs have found here, or what areas they have looked at. And I would say that the AIs are sometimes better at a bigger context maybe than humans, or context in ways that the humans didn't really think about in the past. So I think sometimes the AIs help the researchers to find new ways of finding stupidities or mistakes. So do we then miss out what humans would find instead? Maybe. But if we just find volume enough, that's going to keep us busy anyway. So it's like, sure, if we get 100 bugs, did we miss 3? Should we have 103? Really, if we had more humans? Possibly. But at the same time, I don't think so. Because I think the human ones tend to be more simple than the AI ones. Because the AI ones are really good at making really complicated flows and and figure out how you can actually reach or combine different things to actually do that weird flow or that weird sequence that you never thought about. But no, yeah, you're right, it can be done, and that's wrong.
Thanks for the talk. You mentioned that AIs are really good at finding problems, but not necessarily so good at suggesting fixes. What's your take on how good are they at finding practical ways to exploit the faults they find, and how much does this lower the bar on the attacker side?
Well, then I get a little bit vague, because often when I get those reports, I conclude that an AI has been involved pretty much from the language used in the reporting, because it feels like this isn't written by a human. But when it comes to, it's clear that a lot more people nowadays are providing proof of concept code. And you can tell that they're being written with AI, right? Because AIs write code in a particular way. It's too many comments. No one writes that many comments. In particular, when something stupid like the proof of concept code to prove a flaw, why would you comment that on every second line? But okay, so I can certainly tell that people have used AI to write the proof of concept, and maybe that is more common nowadays. But I can't tell if the AI wrote the proof of code. I mean, if it came up with the idea, or if the human told the AI to write it in that particular way, right? So I don't. In my case, I receive reports that are sent to me by a human, right? So the human have compiled a lot of things here. So I don't know exactly the extent of how is everything AI? Is 10% AI? Is it 85% AI? I don't know. And to me, it's rarely that important. I'm just getting high quality reports at high volumes.
Okay, we're just going to take 2 more questions. So one here and there's one up there.
Yes, thank you for excellent talk. We saw all those projects that have this high influx of security reports as well. And I know you dabbled a bit with Rust a couple of years ago. Is there some analysis around the language or choice, or is this more like logical kind of bugs that are exploited in a particular way?
I don't think anyone has actually made any proper analysis of that, so I would only be guessing if I would have to do that. But out of the 8 I'm going to release tomorrow, not a single one is what I call a C mistake. They're all logical mistakes. So that as I want to say, that they would have happened even if we had used another language, because they were just, bad sequences of doing things or keeping things around that we shouldn't keep things around. Regular old problems you do in programming. So, sure, memory-safe languages will help again for memory-safe problems. But I'm not sure those are particularly common, that these AIs tend to focus on other, at least in my case, they tend to very rarely talk about memory-related problems. They tend to find logical mistakes. But I don't have data enough to say that for sure.
Hi. I'm thinking, you said that volume kept quite high after the slop era. Do you think there could be revenue streams, like maybe hidden and bad revenue streams, keeping the volume high? Or is it maybe just the same people that reported bugs even before the slop era, but just increasing their capacity with AI?
I don't know. Again, that's really hard to say, because I don't have data enough to say or tell. Since I just see my side here, which is a high volume, and then I ask around, and as all those other people say, we see the same thing. But I don't have the numbers, and I can't compare, so I don't know. But I know that a lot of my security reporting, they tend to come from a first-time reporter. They will have cool hacker handles and their digits in their nicknames, and I've never seen them before. They will never come back, and they just show up and they provide an excellent security report. Evil genius 3. But I don't know. Maybe that is the same user as last week, right, with another handle. But I don't know. So it is a curious sort of, where do they come from? Who is behind all of this? But from my point of view, they all seem to be just individuals doing this. And maybe that's wrong. Maybe it's something else. I don't know.
Awesome. Thank you, Daniel. Thank you, everyone.
Thank you.